Okay, we're going to compare the following functions. This is week 14 video. So we have 4 functions, A, B, C, and D. The description, you can have a equation as a description. You can have a verbal description, so it gives you a scenario. You can have a table of values. And here we have another equation. Both of our equations are in slope-intercept form because we have the slope, which is our x coefficient, and we also have the y-intercept, which is right here. This one does not have a number there, so remember that's 0. Okay, so we're going to compare these functions. First, we're going to figure out what the slope is of all of the functions. The first one is in slope-intercept form. So we're just going to look at the coefficient for x, and that is a -5. For B, we have a verbal description, so let's read that. Callie earns $11 per hour babysitting her little brother. She has saved $65 in her piggy bank. Write an equation to show how much money she has. So we'll write our equation at the end. So remember, our slope is our rate of change. So how much is her money going to change each time? So for every hour she works, her money's going to go up or increase by $11. So that is our rate of change. She's earning $11, so it's positive 11. For the table, we need to find our change in y. And over the change in x. That's our formula. So let's look at our y variables. We have 5, 6.5, 9, and 10. We just need to pick 2 pairs. So the easiest ones to find the change in are going to be between 9 and 10. So how much does the y change from 9 to 10? It goes up by +1. So our numerator, our change in y, is 1. And then we're going to look at the change in x on the other side of those 2 numbers. The change in our x value, it goes from 5 to 7. So that is +2. So our denominator, our change in x, is 2. So the slope of that table is going to be 1/2, 1/2. The last one, we have y equals 3/4 x. So again, we're looking for our slope, which is our x coefficient. So it's going to be the fraction 3/4. So that's how you find the slope. We're going to move on to the y-intercept, or initial value, starting point. Sometimes it helps to remember that we also call it the starting point, or initial value, especially for B. So the first one, y equals -5x minus 12. The -5 was our slope, and the -12 is your y-intercept. For the second one, think of it as the starting point. How much money did she start with? It's going to go up by $11 each hour, but she started with $65. So our y-intercept for that one is 65. For the table, what you need to know about the starting point or y-intercept is it's when x equals 0. what does y equal? So in this case, when x equals 0, y equals 6.5. So you just look for the pair, the ordered pair, that has a 0 for the x, and the y is going to be your y-intercept. And the last one, we don't have a number after our x, which means that that one has a y-intercept of 0. So now that we know the slopes and the y-intercepts, we can write our equation. Remember, we always write y equals, and we always have our x. So our x coefficient is our slope, which is -5. So we're going to write -5 right here in front of the x. And our y-intercept is, for this one, -12. So instead of putting plus, we're going to put minus because it's -12. For the second one, we always start with our y equals and our x. Our slope in this one is 11 because her money increased by $11 per hour. And our initial value, or starting point, or y-intercept, is 65. Oops. Plus 65. Our third one, always start with the y equals. Our slope in this case was a fraction, 1/2. Don't forget the x. And our y-intercept was 6.5, positive, so put plus 6.5. And our last one, y equals, our slope was 3/4. Don't forget the x. And our y-intercept is 0, which we don't need to write. So we're just going to leave it as y equals 3/4 x. Now we have some questions that we're going to answer. All right, we have 4 questions we're going to answer. So looking at our A, B, C, and D, which function has a greater rate of change? Rate of change is our slope. So which one has a greater slope? So if you look at your slopes, we have -5, 11, 1/2, and 3/4. So which one is the greatest? 11. So that was B. Second one, which function will graph a negative line? Which one has a negative slope? That's what you're looking for. A negative slope. There's only one, and it is A. The third one, which function has a y-intercept of 0? So which one goes through the origin? And that one is the last one, D. And the fourth one, which function has an initial value that is greater than 50? So on the y-intercept, which one starts at a number greater than 50? That would be our 65, so B. All right, our last problem is we're going to graph the following. So it says you and your friends are going to the Christmas carnival. The admission cost is $6, and each ride ticket is $1. So we are going to figure out the slope, also called the rate of change, We need to know what the y-intercept is, also the initial value, and then we're going to write the equation, and then we're going to graph it. So what we have is two things that we're going to focus on. The admission cost, which is $6. And then we also have the amount of money per ride is $1. So we have two things. We need to figure out which is the slope and which is the y-intercept. So the slope we also call the rate of change. So it's how much something's going to change. If you think about the admission price is not going to change. It's $6 to get in. You pay your $6, you get in, and that's it. But what will change is the amount of money you spend on the rides. It says each ride ticket is $1. So if you go on one ride, the amount of money you would spend would be $1. If you go on two rides, the amount of money you spend would be $2. If you go on 3 rides, you'd spend $3. So as the number of rides changes, so does the amount of money spent. So that is our slope, or the rate of change. Okay, so we're going to put a 1 on that line. And the next we're looking for the y-intercept, which is also called the initial value, or sometimes you can think of it as the starting point. So if you think about the cost of admission, that is going to be the initial value. That's what the amount of money you spend starts at. As soon as you get to the carnival, you have to pay the $6. So your initial value, or y-intercept, is 6. So now we're going to write the equation. Once you know your slope and your y-intercept, you just plug those in for m for the slope and b for the y-intercept. So our equation is y equals mx plus b. Leave a space for your m, x plus, and we're going to write the b at the end. So the x coefficient is our slope, which is 1. And the b, your y-intercept, is positive 6. So we're going to leave that plus and write our 6. Y equals 1x plus 6 is our equation. Usually we don't see that 1 as our coefficient, so I'm going to rewrite this. You would typically see it like this. Y equals x plus 6. So this is what we're going to graph. We know our slope is 1 and our y-intercept is 6. So we're going to come down to our graph. Let's go ahead and mark our positive y. And our positive x. We're not really going to be using the other quadrants of our graph. This is mainly a quadrant 1 graph because everything's positive. And when we get into the negatives, that doesn't really make sense for our example. So we have our y-intercept, which is 6. So on the y-axis, we're going to place our first dot at 6. And our slope is 1. It's a positive slope, so that means we're going to rise up, and we always run to the right. So since that's a positive 1, that means 1 over 1. So we're going to rise up 1, and we're going to run to the right 1. So starting at this dot, we're going to rise up 1 and run to the right 1. You can do that again to get more dots. Rise up 1, run to the right 1. Do it again, rise up 1, run to the right 1. The more dots you have on your graph, the easier it's going to be to draw that line. The more accurate your line's going to be. So let's see if I can connect my dots here. Okay, and I'll make my line continue so you can see what it looks like. And place arrows on it. And we're going to write the equation right next to our line, which is y equals x plus 6. And that's it. We wrote our graph, we wrote our equation, and we graphed it.